Hello everybody. Today we will continue solving questions from AMC 8 2023. Let's continue with question 18. Let's read the question. Greater grasshopper sits on a long line of lily pads in a pond. From any lily pad, Greta can jump 5 pads to the right or 3 pads to the left. What is the fewest number of jumps Greta must make to reach the lily pad located 23 pads to the right of her starting position? Okay, so let's assume that this is the starting point of Greta grasshopper. So this is the starting point of Greta grasshopper. Every time she can jump 5 pads to the right. So she can either go to 5 pads to the right, or she can go to 3 pads to the left. And then after all the jumps, she needs to reach to the place located as 2023. So let's assume that it's somewhere here. So let's assume it's somewhere here. This is 2023rd lily pad. Okay, so let's start. In the beginning, we need to find the fewest number of jumps. That's why in the beginning there is no logic of going to the left. So we will try to reach 2023. Given we need to pass 2023. Okay, so when we divide 2023 by 5, the number, the result will be around 404. Okay, if it's 404 point something something. If it's 404, when we multiply 404 by 5, it's going to be 2020. So it's getting close to here. 2020. So, and then how many steps? So from now on, I'm going to write it. Steps 404, and location is 20th lily pad. So let's continue. 5 more is going to be another jump. How many steps or how many jumps? So maybe we can write this one. Jumps is going to be better rather than steps with jumps. So it's going to be 405, another one, and then we are going to add 5 more. So it's going to be 2025. Can she go back? So when we subtract 3 from 2025, it's going to be 2022. Okay, so it's not our location. So let's continue then. 406 is going to be 5 more, 2030. Okay, so let's go here, 20. So this is 2027, and this is 2024. Okay, so this means we need to continue. 407 is going to be 2035. This time the difference between this number and then this number is 12. This means it's possible to subtract 3, because after subtracting several 3's, we will be able to reach 2023. So let's subtract 408, another jump, but this time this jump is going to be to the left. So this means we are going to subtract 20, 32. Another jump, 409. Okay, we are going to subtract 3 more, 20, 29. There's another jump, sorry, 410. It's going to be 20, 26. And then 411, another jump is going to be 20, 23. Our answer is going to be how many jumps he needs to take, or he needs to make. The result or the answer is 411, 411 jumps. Let's continue. Next question. There is a triangle, equilateral triangle, and then so another equilateral triangle, and then they are, one of them is inside the other one. Okay, and then these ones are trapezoids. How many trapezoids we have? 1, 2, and 3 trapezoids. The side length of the inner triangle is 2/3. The side length of largest triangle. Okay, the similarity rate is 2/3. What is the ratio of the area of one trapezoid to the area of inner triangle? Okay, so the area of one trapezoid over the area of inner triangle. Since the rate of similarity, okay, is 2/3, so this means the rate or the ratio of the areas is going to be 2 squared over 3 squared. This means 4/9. Okay, this means if you are going to write, this one is 4s. Okay, let's find the difference. 9s minus 4s equals 5s. This means the remaining 3 trapezoid is going to cover 5s. So they are also the same as each other. Okay, so because they are congruent, so this means if we divide by 3, it's going to be 5s/3. This 5s/3, and then this one is 5s/3. The total is going to be 9s. So the question is asking about area of one trapezoid is 5s/3 divided by inner triangle is 4s. Okay, when we write it again, 5s/3 times 1/4s. So s and s, they cancel each other. The result is going to be 5/12. The answer is C. Let's continue with the next question. Okay, this is a nice question. Two integers are inserted into the list 3, 3, 8, 11, 28 to double its range. Okay, so we have a list, and then members of the list is going to be 3. I'm going to leave some space. 3, 8, 11, and 28. So we are going to insert 2 integers. Okay, somewhere, we don't know yet. We are going to insert it somewhere, 2 integers. You don't know where. It can be anywhere. You don't know. And then when we do it, range will be doubled. So in the beginning, let's find the range. Initial range was 28 is the greatest number, and then minus the smallest number is 3. Initial range is 25. Okay, so after, the resulting range or final range after insertion of these two numbers is going to be 50. Okay, the mode and median remains unchanged. Okay, what is the mode? Initial mode is what was the mode? Most repeating number. Okay, so 3 is repeating 2 times, while the other numbers are is just one appear 1 time. This means the mode is 3. Let's continue. Median will remain in unchanged. What is the number in the middle? Is 8. Okay, initial. That's right. Initial median is 8. Why? Because it's the number in the middle. Yeah. Okay, so since it's not going to change, we are going to add one number less than 8, and then the other number is going to be more than 8. My question, can it be 8? No, the answer is no, because if we add 8, it's going to be 8, and then the mode is going to change. Okay, yeah, the mode should be 3. If we add 8, so 8 will appear 2 times, or if we add 2 8s, it's going to appear 3 times. In any case, mode will change. Okay, so this means one number is going to be less than 8, the other one is going to be greater than 8, more than 8. Okay, so what is the maximum possible sum of two additional numbers? Because since we are asking about maximum possible sum, what I need to do, I need to make one of the number as big as possible. Okay, so for example, so since final range is going to be 50. Okay. For example, can one of the number be 3? The other number is 53. 53, 3. Because, if I add another 3, the mode will be 3 again. 3 will repeat 3 times, and then, but this is the most repeated again. Nothing is going to change. 53, 3. Mode will be the same, median will be the same, and then range will be doubled. This means 50. Okay, so but can we find some other things? Try 57, 7. So is it going to be possible? 57 here and then 7 here. So it's not going to be possible, because even if he has 57, range is going to be 57 minus 3 is going to be 54. It's going to be 54. Yeah, so this is not the case. Okay, so 57 is not going to be possible. So what we can do, 53 we can add. See, still range is 50, but for the second number I can choose 7. So this means the two number I'm going to add is 53 and 7. Range is going to be 50, 2 times of 25, and mode is still 3, and median is going to be 8. And then because there are 3 numbers before 8 and now 3 numbers after 8, so my answer is going to be 60. Question 21. Alina writes the numbers 1, 2, 3, 4, and then until 9 on a separate cards, one number per card. She wishes to divide the cards into 3 groups of 3 cards, so that the sum of the numbers in each group will be the same. In how many ways can this be done? Okay, so Let's find total number. So when we have all 9 cards together, it's going to be, as we know, from 1 to 3, 4, 5, 6 until 9. The total is going to be 9 times 10 divided by 2 is going to be 45. I mean, the numbers, when we add all the numbers together, we are going to find 45. Okay, conditions. Okay, so let's think about group 1. Okay, group 1. Okay, so let me write group 2 here and then group 3 here. Okay, so let's see. Okay, in group 1, I want to start with 9. Okay, because I want to start with a big number. I'm going to take 9 to group 1. Okay, so since the total number is going to be, I mean, total of all 3 cards is going to be 15 here, 15 here, and 15 here. 5, 1. Okay, and then the other possibility, if we have 9 here, so it's going to be 4, 3. Sorry, 4, 2. Okay, so we cannot write 9, 3, 3 because it's not possible to have the same cards. There is just one 3, and then like 2, 4 is the same as 9, 4, 2. 9, 2, 4 is going to be the same. Right now we started repeating. This means there are 2 possible options: 9, 5, 1, 9, 4, 2, and then all of them is going to, the total of these numbers are going to be 15 and 15. So then, okay, so let's continue. So I want to put 8 in this group. 8 is here, and then the remaining is going to be 7. Okay, but I cannot use 9, I cannot use 5, I cannot use 1 in this case. Okay, so since I cannot use 1, let me start with 2. 9 to 5. Okay, it's not possible because 5 is already there. 9 to 5. Okay, 9. Sorry. 8, 1, 9, 6 is not possible because 1 is already used. It's not possible. 1 is used here. 8 to 5 is not possible. 5 is already used. It's not possible. We use this one. Okay, so let's come to this one. 8, 3, 4 is possible. Okay, and then after that one, 8, 4, 3 is the same as 8, 3, 4, 8, 4, 3 is going to be the same. And then after that one, there will be repetition. So if we are choosing, our first card is 9, 5, 1, and the other group members are going to be 8, 3, 4, and then the remaining is going to be 1 is used, 2 is not used, 2, 3 is used, 4 is used here, 5 is used, 6 is not used, and 7 is not used. Okay, the remaining is going to be 2, 6, 7. Okay, so let's write, if the group 1 is 9, 5, 1, second group is going to be 8, 3, 4, and then third group is going to be 2, 6, 7. Okay, so let's continue with this option. If we choose our first group as 9, 4, 2, okay, what can be this second one? I want to start with 8. I want to put 8 in the second group. Okay, so 8, and then the remaining is 7 to make it 15, make the total 15. Okay, so then can I use 7? No, because it becomes 15. So 15, and then we need to put 0, and then it's not possible. Okay, can we do like 8, 6, 1? It's possible because we didn't use 8, we didn't use 6, we didn't use 1. It's possible. I was supposed to write 8, 5, 2. Is it possible? No, it's not possible because we used 2 before. Okay, we cannot do it. 8, 4, 3. Can we do it? We cannot do it because we used 4 before. So 8, 3, 4 is going to be the same. 8, 2, 5 is going to be the same as this one. So that's why we are done. So our second possibility, 9, 4, 2, 8, 6, 1. And then for the remaining numbers are going to be 1 is here, 2 is here, 3 should be here, 4 is here, 5 is not there, so 5, 6 is here, 7. And then total is going to be 15 here. So this means there are two ways to do this. Let's continue with the next question, 22. In a sequence of positive integers, each term after the second is the product of the previous two terms. The sixth term in the sequence is 4,000. What is the first term? Okay, so we have the first term, second term, third, fourth, fifth, and sixth. Okay, sixth term, yeah. And then let's assume that the first term is m. The second term is n because we don't know the product of the first and second term. Fourth term is going to be product of second and third term. M times n squared. Next one. Fifth is going to be the product of third and fourth term. M squared times n cubed. Sixth term is going to be the product of fourth and fifth term. Is going to be m cubed times n to the power 5. Sixth term is going to be 4,000. This means m cubed n to the power 5 is going to be equal to 4,000. Okay, so we need to do prime factorization of this 4,000. Let's do it somewhere here. 4,000. Okay, so let's do it 2 times 2,000. 2 times 1,000. 2 times 500. 2 times 250. Okay, 2 times 125. Okay, 125 is 5 times 25, and then this is 5 times 5. This means the result is going to be 1, 2, 3, 4, 5, and 1, 2, 3, 5 cubed. Okay, so in this case, we can easily say m equals 5, n equals 2. Okay, the question is asking what is the first term, and then the first term is m. This means m is 5. Next question is asking about kind of probability. Each square in a 3 by 3 grid is randomly filled with one of the 4 gray and white tiles shown below on the right. Okay, so the possibilities is going to be either this one or this one, either this one or this one. So one of them will be chosen. What is the probability that tiling will contain a large gray diamond in one of the smaller 2 by 2 grids? Below is an example of such tiling. Okay, so what is the example? See, as you can see, what is the probability of having this one on here? So there are 4 possibilities. So we are going to create this diamond shape either here using these 4, or we are going to use these ones, these 4, or we are going to use this space, these 4, or the last option is going to be these 4. And then for each one, the probability of creating this diamond is going to be the same. Let me find the probability of creating this diamond in one of them. So this means we need to multiply by 4. Okay, so how can we create this diamond? What is the probability? Okay, so probability of getting this tile here is going to be 1 over 4. Okay, so it's going to be 1 over 4. So getting this one, because we have 4 options. 1 over 4. How about this one? It's going to be 1 over 4 again. And then this, this one is going to be, this is going to be 1 over 4. And then the last one is going to be 1 over 4 because we have 4 different options. So it's going to be 1 over 4 to the power 4. Okay, so this is, but this is, as I said, we need to multiply this probability by 4 because we have a similar probability here, 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 and then here. So this means we need to, when we multiply this one by 4 times 1 over 4 to the power 4, the result is going to be 1 over 4 cubed. Yes, the result is 4 times 4 times 4 is going to be 1 over 64. The answer is C. 24. We are getting close to the end. Isosceles triangle ABC has equal side lengths AB and BC. Okay, so this one and this one is equal. In the figures below, segments are drawn parallel to AC. So this one is parallel to this one. These are parallel. So that the shaded portions of ABC has the same area. This means this one and this one has the same area. Since the total distance or total height is going to be h, and then this is going to be 11. Okay, h over 11. So this means the area of this one, let me write E, B, A, B, C, D, E. Okay, the area of A, D, E over area of A, B, C equals, so 11 over h squared, 11 squared over h squared. So this one, we know this one from similarity. Yeah. Okay, so let's continue with here. Okay, this one is going to be, we don't know, let's say FG the ratio is going to be BFG, area of BFG. Okay, so this one is also area over area of ABC equals, this time, h minus 5. This one is h minus 5, this distance, h minus 5 squared over h squared. Since this area and this area, this area and this area is equal, we can add, let's say, the ratio of this area over the whole plus the ratio of this area over the whole is going to be 1. So the ratio of BDE to the whole is going to be 11 squared over h squared plus the ratio of this one to the whole, which is the same as this one, is going to be h minus 5 squared over h squared is going to be 1. Yes, I hope you get the point. 11 squared is 121 over h squared. Okay, plus, so we are going to find this one, h squared minus 10h plus 25 equals 1. In this case, so we can do cross multiplication. So a little bit difficult now. We can after the cross multiplication we can write 121 plus h squared minus 10h plus 25 equals h squared. Okay, so we can cancel h squares. Okay, so let's add these numbers together on this side. 1 4 6 equals 10h. Okay, so to find h, let's divide both sides by 10. Here is going to be h equals 14.6. Okay, the answer is A. Let's continue with the next question. This is the last question of AMC 8 2023. We have 15 integers from A1 to A15. They are arranged in order on a number line. The integers are equally spaced. This means the distance between them, between two of them, consecutive ones, are the same. Okay, so it's a what arithmetic series? Okay, we have property that A1 is between 1 and 10, A2 is 13 and 20, A15 is going to be between 241 and 250. So what is the sum of the digits of A14? So let's if we remember our arithmetic series, we do like this: AN equals A1 plus M minus 1. So let's see the distance between them is K. Okay, so then A2 is going to be equal to A1 plus K. A15 is going to be A1 plus 15 is going to be subtracted 14K. Okay, so if when we put all of them together, so let's put here first 13, let's A1 plus K 20, and then again 241. Rather than writing A15, let's write A1 plus 14K. A1 plus 14K less than or equal to 250. Okay, so then I will try to find K. That's why I need to subtract A. Okay, so sorry, A1. So, but we know that A1 is between 1 and 10. Okay, so since I need to subtract it, so I need to multiply both sides by -1. Okay, so but all signs are going to change, and then all let's say less sign will be greater sign. What I'm trying to say, A is going to be negative A1 is going to be -10, between -10 and 1. Okay, so let's write all of them: -10, A1, negative A1, and -1. Okay, so and then let's write this one again. A1 is going to be -10, negative A1 is going to be -1. So when we add them together, A1 is going to be, sorry, K will be between 3 and 19 in this case. Let's look at the second case. Let me draw this one nicer. 231. A1, they are cancelled out. 14k, 249. Okay, let's divide both sides by 14. When we do this one, we will find that k is going to be between 16.5 and 17.78, and it will go ahead like this. And so k is equal to 17, because the distance between the numbers like a1, a2, these are the distance like k. So it should be, since a1 is an integer, a2 is an integer, k should be an integer also. Okay, that's why. Okay, then if k is 17, let's write everything again. Okay, so what we know right now, we know that a1 is going to be between 1 and 10, 13, between 13 and 22, 20. But a2 is a1 plus k, which is 17. a2, which is a1 plus 17, is going to be between 13 and 20. Subtract 17, the result is going to be a1 is going to be between -4 and 3. Okay, so 241 equals a1 plus 14k, 250. Okay, 14k, 14 times 17, 1 times 7 is 7 plus 2, 98, 14, 8, 3, 2, 38, 238, when we add them together. Okay, 241 a1 plus 238 equals 250. So let's subtract 238. a1 is greater than 3 and less than 12. Okay, so what can be a1? In the first one, we are saying a is between 1 and 10. A is between 1 and 10. In the second one, we are saying it's going to be between -4 and 3. This means we are limiting. It cannot be greater than 3. This means in the second one, we are limiting our a1s between 1 and 3. And then in the third one, we are saying it should be greater than equal to 3. So now we found our a1s are, our a1 is 3. Okay, our a1 is 3. We need to find a14. Okay, a1 is 3. a14 equals a1 plus 13k equals a1 is 3. 13 times our k is 17. 3 plus 17 times 13, 21, 51, 17. Okay, so the result is going to be 221 plus 3 is going to be 224. Okay, the sum of the digits of A14 is going to be 2 plus 2 plus 4 is going to be 8. I hope you enjoyed the video and found it very beneficial for you.